All right, last lesson of the unit, modeling polynomial functions. Well, we've done this in grade 11. We modeled quadratic functions. Remember the parabola, where you had to say, well, what would be the maximum height, when did it happen, so you'd find an x and a y value. Or maybe I asked, when would the pumpkin hit the ground, or when did it start? Okay, this would be time, this would be height. All right, that's the kind of question you did in grade 11. In fact, I don't know if you remember this, but here's a little flashback to what a quadratic equation might have come from, the idea of shooting a pumpkin. Let's try this. Oh my goodness, that's too good. So, if the pumpkin or the watermelon would have taken off, it would have made the path of a parabola. Now, when you get to grade 12, we're no longer talking about parabolas. Usually they're going to be cubic functions. Okay? So this time, instead of trying to come up with the equation of a quadratic, we're coming up with the equation of a cubic. So let's see what this one says. This one says you got a piece of cardboard. So let's draw a piece of cardboard. Here's a rectangular piece of cardboard that is 30 centimeters by 25 centimeters. And you're going to make a box out of this by cutting out corners. And the corners, we don't know how big we should make them, but they're supposed to be square. And by cutting out 4 corners like this, you would fold along these dotted lines, and you're going to make a box. The box would look something like this. Okay, be something like that, right? With this length being the x value, this being along here. Okay, so let's try to figure out how to draw this, how to figure it all out. So we're going to figure out the volume of the box, and it's going to be length times width times height. What would be the length? Well, we're given 30 centimeters, but we're going to cut out 2 boxes that are x length. So you're going to get 30 minus 2x. Then the width would be 25, but again, you're going to cut out 2 boxes, so you're only going to have 25 minus 2x. And then, if we fold along these dotted lines, how high is the box going to be? Well, it will be x high. And there's your equation of a cubic function. How do I know it's cubic? Because x times x times x. Now, if I wanted to graph that, x-intercepts are ready to go. They're 15, they're 12.5, and they're 0. So let's put that on a graph. Here's 0, here's 12.5, here's 15. All right, and what would this graph look like? Well, it's a cubic, and the lead coefficient will be positive. Why? Negative 2x times negative 2x times x will give you a positive 4x cubed. So that means this cubic will look like this. In between here, you're going to get a curve, you're going to get a curve that looks something like that. Let me just move that over a little bit. Okay. Now, that's what the graph looks like, but really some of these parts are irrelevant. For example, this is irrelevant. Why? Well, x can't be less than or equal to 0, because x is how much I'm cutting out of the cardboard. If I don't cut anything out, I don't have a box. And I can't cut a negative amount. I can't make the box bigger. For that matter, this is irrelevant too, because x can't be bigger than 12.5. Because if it is, think about that for a second. Here's our box. If we make these cutouts 12.5 by 12.5, and we do the same thing here, what's 12.5 plus 12.5? It's 25. And this whole length is only 25. So for our purposes, really this graph only exists here. The domain of this graph is from 0 to 12.5. Okay? Now if we were wanting to and we had the technology, we could figure out what is the maximum volume by graphing. But you won't be asked to do that. You may be asked to do it algebraically. So let's try a question like that. Okay, first one. I'm going to tell you right now, I won't ask this on the test. You probably won't see one like this. It's a little bit tricky. Okay, we have Clara's age, we have Leslie's age, we have Mike's age, and Thomas. And each one is related in some way. It says Clara has 3 friends. Leslie's 5 years younger than Clara. Mike is 2 years younger than Clara, and Tom is 3 years older than Clara. We know the least about Clara, so we're going to say, let Clara be X. Now it says Leslie is 5 years younger. It says Mike is 2 years younger, and Thomas is 3 years older. So you have these 4 ages. Okay, now it says on March 11th, the product of their ages. Okay, how do you get product? You multiply. The product of their ages was 61,136 greater than the sum of their ages. Okay, hang on. Let's add their ages. Well, which one's bigger? The product was bigger. So not equal, bigger. How much bigger? Well, this one I would have to add 61,136 to. And now you have an equation. This is going to be a quartic because it's x to the 4. And I'll tell you, I've never seen you have to solve one like this because it gets pretty ugly. This number is just too big for us to factor without a computer. I think if you were given this question on Desmos, you could do it. But for us, we're going to leave it. Instead, you should focus on ones like this. This is a very common question. Okay. It says the height of a square box. So let's draw a square box. The height is 4 centimeters more than the side length of the square base. In other words, the length and the width of this box are both the same. The length is x, the width is x, and the height is 4 more. The volume is 225. So the volume, you would multiply x times x plus 4, and we're being told that volume is 225. And if I multiply this times this times this, I get x cubed plus 4x squared. Now, how do you solve this? Well, this is actually something we know how to do. Alright, we want to find out when this exists. In other words, we need to factor this. So, to factor it, what goes into 225? Plus or minus 1, plus or minus 5, plus or minus 15, etc. Okay, so let's try. Let's try x minus 1. If I put 1 into here, I get 1 cubed. It's 4 times 1 squared minus 225. you can see that's nowhere near 0. Let's try x minus 5. So this is 5 cubed plus 4 times 5 squared minus 225, which equals 0. Yes, x minus 5 is a factor. So going back, I get x minus 5 is one factor. What are the other ones? Well, to do that, I have to do synthetic division. 5 goes into this. 1, 4, 0 placeholder of 0, and then negative 225. 5, 9, 45, 45, 225, 0. So there is our product. This actually can't be factored. You could check that using b squared minus 4ac, but it can't be factored, meaning there is only one solution. The solution is x equals 5, which means the dimensions for this box are 5 times 5 times the height is 4 bigger, so 9. And if you multiply that, you do get 225. So we figured out the dimensions of the box. Okay, that question is pretty common. I would expect 1 on the test, possibly. It's the only question in terms of word problems that I've ever seen on a final exam. So I would try to do a few of these. I think the other ones you can try, but I don't think I would spend too much time on them. All right, this one though, I would try. It's a little bit more difficult, but possible. Okay, so that's the end of our unit. I'll give you some homework. All right, it's page 61. Now, some of these questions you're not going to do. I would say stick to the area volume ones. Okay, maybe leave the other ones for now. Try the review. Try the on the My site, on our school page, there is a long review for this unit. I would make sure I try some of those, okay, because you haven't been in class for this unit, so I want to make sure you understand. Once you think you understand, okay, star here. Once you think you understand, I'm going to post a practice test. If you would like, you can do the practice test and submit it to me. Email it to me, I'll mark it. It won't be for marks, it'll just be for you to see if you are understanding this unit. Okay, so what I would do is do the work, be neat about it so I can read it, send me a picture through email, and that'll be our first chapter. Okay, I would say have that done sometime next week, because after spring break we will start the next unit. Okay, so the practice test will be posted in the unit. This unit was polynomials, so look in that unit. All right? Good luck.